Welcome everybody to this webinar. I'm excited to have two partners in on this presentation today, PowerFilm and F3 Wireless. I'm Joe Ward with EPs. We have an exciting agenda here for you today. There is a chat line. If you have questions, please type in your question and we'll try to get to them at the Q&A at the end. We're each going to present for 15 minutes and then have a little Q&A at the end. So thanks for your time. I hope you enjoy the material, and I'm going to turn it right over to Sam from PowerFilm. Sam, take it away.
Hello, thanks everyone for attending. My name's Sam Jones. I'm an engineer at PowerFilm Solar. We have been manufacturing and providing custom solar solutions across a lot of different industries for the last 30 years. And many of our solutions are really closely tied to this idea of energy harvesting and low power electronics. So I'll go ahead and jump right in. So I like to start out with this slide. It kind of gives a really good tangible sort of example of how the answer to this question of what can I power with solar energy harvesting. So on the left here you see an indoor solar panel, our LL200-337. It's one of our standard designs. And if you were to ask me what can I power with this panel, I may respond in this way. It's kind of based on three things: location of the device itself, and then how that device is being operated. A lot of our customers are using Bluetooth Low Energy. It's an extremely low power protocol. It's great for IoT, and it's really, really well compatible with energy harvesting. So I like to use that as an example because it can be configured ultra low power, but it can also be configured into some higher power consumption modes. So if you take this panel and you put it underneath of a desk, it's a pretty dim environment. You may get 50 lux. Lux is just a fancy way of measuring light level. But we'll get some power, and we can usable power, and we can take that BLE device and maybe we can configure it in a beacon mode and add a passive sensor like a temperature sensor. We'll have enough power to update that about once a minute. If we take that panel and move it on top of a desk, we'll get even more power. We can actually support a live Bluetooth connection, and we can update that temperature data about once per second. If we take that panel and we place it near a window, we'll get it'll be a brighter environment. We'll get a little bit more power. We'll have enough to update maybe 10 times per second. Outdoor shaded environments are going to be even brighter. You get enough power to start exploring some of the higher power consumption modes of BLE, like setting the device up as a gateway. We may not have enough power to power that 24/7, but you could set up some sort of partial duty cycle. And then the maximum would be pointing the panel directly to the sun, and you would get enough power to potentially run that gateway 24/7. So hopefully this is a good example of just how stark of a difference location and operation of a device is when it comes to an energy harvesting solution. A BLE device that's updating once per minute could potentially consume 10,000 times less power than that same device that is operating in an always on mode. And likewise, the solar could produce 10,000 times less power under a desk than it does in direct sunlight. But both of those scenarios are very useful functions, especially for IoT. So which moves me to my second point. What should you consider for PVs for energy harvesting IoT applications? So kind of like the previous slide, I mean, even the same device can be configured in different modes. And think of all the thousands and thousands of devices out there. There's so much diversity that, I mean, no one PV solution looks alike for different applications or energy harvesting solutions. So when a customer comes to us, we like to define requirements, and then we build and design a solar solution that then meets those requirements. So I've kind of compiled a list of what are the common requirements that we build and design to. So the first When you're talking about PV, you're talking about light. So those are two of the most important parameters up top, the light intensity, and then the spectrum. So what type of light you are operating under. And both can have a huge impact on whether or not that solar panel will work. I mean, are you in direct sunlight or are you in a dim warehouse? You want to make sure that whatever PV cell you are sourcing is kind of optimized and rated and spec'd for both the light intensity that you're going to be under, whether it's outdoors or indoors, and then that spectrum. So, I mean, some panels are optimized for a solar spectrum, and then an artificial light spectrum may not have all the components of that outdoor spectrum, so that panel going from an outdoor environment to an indoor environment may not work the same way. It may not work at all. So you just want to make sure that you are choosing the right PV cell for the intensity and the spectrum of your application. Then you have the kind of the physical traits of the panel. I mean, does it need to have weatherproofing? Does it need to be UV resistant? A lot of the panels that we spec for our outdoor applications have both IP67 and UV protection, like the crystalline panel that we built for a refrigerated trucking unit. It's fully IP67 because the panel itself is exposed. But something like the bike lock takes one of our standard duty panels and puts that into a weatherproof UV resistant enclosure. So that just kind of gives you some more options and for kind of to meet your needs. You could potentially lower some cost. And then finally, the durability and longevity is extremely important, especially for an energy harvesting solution. You want to make sure that the PV component of your solution will last long enough to realize your business case or your rate of return. I mean, for a lot of times we're sort of racing the clock against the battery dissipating, and that's kind of as soon as that battery dies and we have to replace it, or I mean, that's when the economics make sense to kind of implement these energy harvesting solutions. So durability and longevity definitely plays a huge role in the PV component of an energy harvesting solution. Then you have considerations that are kind of specific to the device and then the solar panel related to that device. So, I mean, at the top here, you see power generation. And I listed it first, but you may be surprised that power generation is not always the #1 critical criteria for design. I mean, these devices that we're talking about are so low power that often like size and dimensions and mechanicals and cost are larger, more important, more critical parameters than actually the power generated by our PV. So the #1 thing for power generation is kind of to thoroughly understand the device power consumption that you have so that you know that you're generating enough power. I mean, I think Joe and Chris will definitely go deeper into that. But that's usually a great place that we start is kind of understanding that power requirement. And then size, and I put thickness and flexibility up here. PowerFilm's core technology, amorphous silicon, is thin film and flexible. So we work with a lot of applications where that's kind of required. That's sort of our niche. So I mean, we know a lot about that, and that is definitely a requirement for many applications. Just knowing the surface area that you have available to put solar, and then kind of what are the requirements around that. In the top right picture up here, we had a Bluetooth demo with a Nordic chip on it, and it's kind of demonstrates how you can use a thin film panel in sort of a flexible way, and that actually doesn't even have a battery on it. I thought that's pretty cool. Then I have mounting and wiring. So sometimes people think about as an afterthought. The concept of energy harvesting and solar is pretty, I mean, at a high level, it's pretty simple. But when you get down into the details, you realize that, wow, this panel is going to have to be mounted somehow to my system. It's going to have to integrate with my device. And it's going to have to be somehow electrically connect to the panel. whether it's wiring or PCB. I show a picture of one of our panels mounted to a PC board. So we kind of have a lot of options. There are definitely a lot of options available that make integrating the PV cell into your system as easy as possible. But it's always good to keep that in mind and define that requirement as you're building your system. And then finally, cost and volume. So you just want to be able to make sure that the PV that you design and develop, it's going to be able to scale to meet your expected volume. And then obviously the cost requirements. So a lot of IoT applications are really cost sensitive. Like I was saying, the rate of return is kind of dependent on time, and lower cost means higher return. So you definitely want to keep that in mind. Not all PV technologies, they cost different amounts, and some are able to be manufactured at different scales. So a solution at 1,000 unit quantity may look different than a solution that needs to reach 1 million or 10 million unit quantity. And then finally, I'll go over some of the available PV technologies that you can use for IoT solutions. Starting at the top, I'll go over amorphous silicon. That's our core technology that we build here at PowerFilm. Like I said, we also provide solutions with crystalline silicon and gallium arsenide for some military and space applications. We've evaluated organic PV and some of that. So some of the advantages of an amorphous would be indoor performance. You can make it highly custom. I'll go over that in the next slide. It's thin, flexible, durable. We do 100% roll-to-roll manufacturing, so that it can be actually very economical as well. Crystalline silicon is kind of your traditional solar technology, like what you would see on a rooftop. It's great outdoor performance. It can be low cost, but it has some size limitations. You can find small, tiny crystalline panels. You can find big panels, but I would say it's less customizable, at least for PowerFilm. If you asked PowerFilm for a custom crystalline solution, we would have some size limitations. And because of that crystalline nature, it can be less durable, especially for larger panels. Some of the smaller panels don't have durability issues. Gallium arsenide and some of the other 3-4 technologies, they have extremely high outdoor and indoor performance. I show this graph of power density under a cool white LED spectrum. And you can see gallium arsenide blows amorphous silicon and crystalline silicon out of the water for power density. Also interesting to note that crystalline silicon, although outside would perform higher than amorphous silicon, when you bring it inside, it's missing that infrared component of the spectrum, and the amorphous silicon actually outperforms crystalline silicon in an indoor environment under artificial light. OPV could be the solar of the future for IoT. It has similar indoor performance as amorphous silicon. They promise really high performance. It could also be thin, flexible, even printable. We recently were evaluating an OPV supplier to potentially bring that online as another kind of tool in our tool bag for custom solutions. But that specific technology, we did see some scale up and longevity issues. So definitely when you're evaluating your PV sources, you want to kind of draw all these criteria and make sure that the benefits and the drawbacks of each technology kind of align well with what your requirements for your application are. I'm running out of time. So real quick, I wanted to end with our kind of do-it-yourself customized PV tool. This is a tool that we kind of launched to help customers design their own solar panels. So I'm an engineer and I don't like talking to people. So if there's something I can do by myself, then I'll do it myself. So this is kind of that idea. You can see our panel here has a couple cells on it. The vertical columns are cells. They're connected in series with silver interconnects. So if we add cells in series, it'll increase the voltage while the current stays the same. That's one way we can increase or decrease the length of the module. If we can actually change the size of the cell itself. so we can also decrease or increase the length of the cell. And since the number of cells is staying the same, the voltage does not change, but the current will go up and down. So we can change the dimension that way. We can also make thinner or wider cells. A lot of applications we work with are long, skinny panels because that's relatively easy for us to do, and it's a little bit more complicated for other technologies. You can specify indoor versus outdoor. So you'll see for indoor panels, they're spec'd at different light levels. Then we have a bunch of our additional options, and this isn't an exhaustive list, but we have UV protection, weather seal contacts. We can make the tape black, adhesive on the back to make the panel peel and stick, custom design. You can change the bus bar so that the connections are easier. And then you can submit the design, and our sales rep will follow up with you and let you know how you can source the panel. I'm out of time. I covered everything I wanted to. So I will now hand it off to Joe to talk about what needs to go in between the solar panel and the device to make sure that your system is functioning good.
Thanks, Sam. Yeah, there's been some questions come up on the chat, but as I mentioned at the beginning, we'll address those at the end of the presentation. So we have a chance to get through the 3 presentations here. So do you see my screen okay? Sam, does that show up on your side?
Yep, I can see it pretty good.
Great. Okay, thanks. So number 2 of the 3 presenters, my name is Joe Ward. I'm with EPs. You see my email address there. If there's anything that you need, feel free to contact me. But we're the EPs, you're wondering what that stands for? It's Electronic Portable Energy Autonomous Systems. We're a fabless semiconductor company based in Belgium. Been around for a while, but we're all about energy harvesting. We've got about 15 patents for protecting our intellectual property. We're growing fast, almost up to 30 employees worldwide. But we're in the exciting area of energy harvesting, and it's exciting for a lot of the reasons. Like actually, just seeing Sam's presentation again, I'm so amazed of the innovations, advancements made in the PV cell world, which helps us because we're all about working with partners like Sam, like PowerFilm, in developing energy harvesting circuits. But our vision is to help eliminate the need for batteries. Batteries are everywhere. They're in all sorts of consumer products and healthcare products, but the big growth for this market is in IoT sensors. And if you've seen the analyst numbers that are shown here on this slide, the projections are huge. There's going to be billions and billions of these sensors in the next 5-10 years that are going to be wireless and going to be run on batteries unless they figure out a way to get rid of the battery. And just about everybody I talk to in this area has issues with battery life. And so that's,
Joe?
Yes.
I'm sorry to interrupt. I just want to let you know, you have the presenter view going to us, just so you know. You may want to swap screens.
Yes.
Just a heads up. Sorry to interrupt.
No problem. Let's see.
Usually you can do that same thing and just hit the swap screens.
Right.
The pull down menu at the top. If you go into the presentation mode, see display settings at the top. I can see it. Yeah. Try swapping. That usually does. Yep. Perfect.
That work?
Yes, sir.
Okay.
Thank you.
Okay, great. So, but yeah. Anyways, I was just saying that the market size is huge because there's so many of these sensors, and it's in every market segment that you can think of for industrial, retail, transportation and logistics, automotive, agriculture. Everybody is looking at ways to do IoT networks and to get data, and so there's billions of these sensors out there that have batteries and have battery issues. And it's not just the use of the battery and the short life of the battery. It's disposing of the batteries. It goes on and on. So you can see the appeal for the need to get rid of those batteries or to extend the battery life. Our core competence is in low power. We develop semiconductor solutions that leverage proprietary design methodologies and approach to increase device autonomy. You can see, this block diagram at the bottom that has your typical edge device, and we're in that quadrant about, that talks about power management. It's all about managing the power from a source and a storage element and making sure you have enough power to drive your sensors and your communication and your processing. So what EPs does is we have a family of AEMs, which is ambient energy managers. The industry kind of refers to these as PMICs, but we call it AEM because it's a little more appropriately named. And we have a device for each type of energy source. Photovoltaic is certainly the most popular for the reasons that Sam mentioned. There's been so much innovation there, and the performance and the efficiencies and the cost are getting better and better. But there's also applications for thermal, for vibration, and for RF energy harvesting. And there's some really interesting, unique applications that are harvesting those energy sources. And as you see in this chart, vibration and RF are typically AC sources. So you need an external rectifier with our device to make sure you get to a DC voltage for the power entry. And as I mentioned, there's so many different use cases that are out there. This is a quick, short list of some of the customers integrating our devices, and you can see some of the uniqueness of the applications. Agriculture, asset tracking, which is a huge vertical right now. Everybody wants to track things, people, pets, products, everything, and so there's a lot of opportunity there. Predictive maintenance. A lot of industrial companies want to know when the products are the equipment's going to fail in advance, so they have sensors on there measuring vibration and measuring temperature and fluid levels and on and on. Electronic shelf labels, another huge market for retail, where they want to change prices on displays. Huge in grocery stores and retail places. So amazing. And if you think about all these use cases, changing the batteries is extremely difficult, or if the batteries die early, it's very costly. So tremendous market opportunity for energy harvesting. So as to summarize, IoT devices are deployed in high volumes, and battery replacement can be a real headache. And just doing one or two devices, not that big a deal, but when you talk about thousands or tens of thousands, it's a problem. So energy harvesting offers you solutions to those problems, and it removes the maintenance and cost issues. So some of the reasons why you want to consider energy harvesting: you can reduce your storage volume, you can extend the life of your product, you remove the maintenance costs, and you add features. A lot of times we talk to customers that have sensors, they're just doing temperature or humidity, and they want to add motion sensing or other sensors, but they can't because of the power budget restrictions. Well, with energy harvesting, that often will allow you to add more features, or maybe it'll allow you to do your transmit and receives more often. Sometimes people can only transmit and receive 3 times a day because of power restrictions, but with energy harvesting, they can do it every 5 minutes or every 15 minutes. There's a lot of capability you can add if you loosen those power restrictions, and that's what energy harvesting allows. So what is it? It's taking this source, and as I mentioned, PV cell is certainly the most popular, but there's also RF, thermal, and vibration and electromechanical. So you take that source of energy and you store it and you drive some hardware with it. That's what it's all about. But you need an AEM in there. Oh, can you still see my, did I mess up here? I got a mixed view.
We can still see your screen.
Okay, okay. I have 2 monitors going, and one of them changed on me, but thanks, Heather. So you need an AEM in the middle because there's certain things you have to manage when you've got an energy harvesting circuit. One is extracting the maximum power from the harvester. You know, if you've done any work in this area, you know that there's power curves that change depending on the light intensity and the open circuit voltage. What our device does is monitor the maximum power from the source and make sure that you're getting the most efficient harvesting done. It also has this feature called cold start, which is to start boosting power from ultra low levels of of the energy source. That's called a cold start. And then it also manages the energy transfer extremely efficiently. So why do you need something in between the harvester and the storage element? To manage the power, the maximum power that I talked about, to enable the cold start, so you can drive your circuit from ultra low power, like in the order of 3 milliwatts, microwatts. And you want to be able to protect your storage element, and you want to be able to supply a regulated voltage to your application. These are the functions integrated in the AEM. And it's so easy to use. There's no software. There's some configuration pins. So depending on the type of storage element you're going to use, if it's going to be a cap or a super cap or rechargeable battery, you can set some pins so that you get proper configuration. Very easy to operate. So to summarize, the AEM handles the maximum power point. It manages the cold start. It manages the storage elements. It provides 2 regulated outputs to your hardware, one high voltage and one low voltage. High voltage typically drives a radio, and the low voltage typically drives a micro or some circuitry. You can see the cold start parameters there, 3 microwatts or 380 millivolts. You see the leakage listed here at 400 nanoamps. That's extremely low, which makes the device extremely efficient. And as I mentioned, there's management of the storage elements, so it's not overcharged or over discharged. There's an additional feature. Our goal is to eliminate the battery completely, but some applications you just can't do that. They have to have a guarantee on time, or maybe the harvesting source, the energy, might not be reliable enough. It could be in the dark for weeks on end. So some people opt to still have a primary battery. Often it's a very small battery, but it just gives you that security of having the always on capability. But our device allows you to manage that into the circuit, the primary battery. Okay, so what makes the device unique? You see on the right here a block diagram of the AEM, and you see a block for the cold start. You see a block for the maximum power point transfer. You see the boost circuit, for taking that low level of energy from the harvester and driving the storage element. And the buck and the LDOs are there to drive the outputs. And you have the option for the primary battery. So what makes this really unique is the low power cold start that we're able to do, the minimum boost voltage, the low quiescent current, the bill of materials. This is really important. There's other competitors out there, but often those require 15, even 20 passives or resistor networks around. Our device requires only 7 passives. I think it's 5 capacitors and 2 inductors. So a very small footprint. You have the option of the primary battery. We have the ability to manage dual cell supercaps. We have a balancing circuit that we can access that's very effective, and it's a unique feature. And we also have the ability to open circuit and constant impedance MPP tracking for certain applications. So it's very flexible. It's very easy to integrate. It's very, very energy storage flexible. So, okay, the product details. I won't go through all of them today. I'm just going to focus on the AEM 10941 because that is our device for PV cells, and that is the thrust of this webinar. So this is the device. It's been in production. You see down at the bottom that it's showing available in a QFN, but we will be introducing a CSP package in the second half of this year, which is extremely small for those very size constraints applications. You see the list of the passives right here that in the bill of materials. As I mentioned, some capacitors and inductors. Here's the block diagram up the top. The cold start levels are listed here, and the maximum input for the device is 5 volts, 110 milliamps. So some people come to us and ask about driving higher power circuits, but we really are limited. And so we're really good at the lower power end of these applications. And but you see the buck boost efficiency up to 95%, which is extremely good. We have a very unique MPP tracking system that does the the pulsing of the harvester to make sure that we're locked in at the maximum power point. So it's a very unique feature. You see the leakage current here at 400 nanoamps, which makes the device very efficient. Primary battery option, and then the configurable high voltage output and the fixed low voltage output. And then of course the storage element protection to ensure you don't over discharge or overcharge the device. We have a lot of information to help you in analyzing your energy harvesting circuit and getting information on the devices. We have data sheets, we have evaluation kits with user guides and quick start guides and other documentation. And my apps engineer just told me we'll have an app note out in the next few days summarizing all of the advantages or of the app, the details of doing an application with this device. So if you're interested, please contact me or check out our website in the next week. Okay, let me check my time. Oh, I think I'm just about out. Well, okay, let me take one more minute here. So we can assist with this, your process of looking at and doing a power budget analysis on your circuit. And what will energy harvesting provide you? Can you get rid of your battery? What kind of storage element do you need? What kind of front-end energy harvester can you consider? We can help with that, but these are some of the questions you have to ask. Defining your environment, estimating the device consumption, selecting which AEM you'll use, calculating the power required at the harvester so that you can best choose the right device, and then calculate the energy to be stored so that you can make sure you have the right storage element and using the right size and technology. So I'm going to skip a couple slides and go to my last one since I'm out of time. But again, please check out our website. Here's my email. If you have any questions, feel free to contact me. And at the bottom, I listed one of the contacts from our distributor here in the U.S. Robert Grambo is one of the contacts. He can, if he's not the right person, he'll direct you to the right person. But Fujitsu Electronics America can work with you on helping to get pricing or evaluation kits or getting getting units or whatever you need. So that's my last slide. I appreciate your time and attention. I'm going to turn it over to Chris at F3.
Dokey. Let's see here.
All right, Chris.
All right. Hey, everybody. My name is Chris Anderson. I'm with F3 Wireless. I will dial up our little presentation here as soon as Joe is done. And we can kick off and talk about the actual device development. Joe, can you?
There you go. Sorry.
I'll
figured it out.
And I got to make sure I share the right thing. Alrighty.
All right, it's up. Thanks.
There you go. F3 Wireless. So we'll just pop down to the next one here. There we go. A little bit about me. My background is RF in general. I've done stints at radio companies, design services companies, antenna companies, module companies, industrial companies, worked on railroad stuff and aircraft and consumer electronics. And basically, if you can think of it, I probably touched it somewhere along the way. But the overall the overall theme is somewhere in that thing, in that product, there was a radio. A little bit about F3 Wireless. What do? We do consulting, design, and manufacturing services for custom wireless products. If you're an engineer and you've never built a product with a radio in it before, RF products and RF electronics are some of the most sophisticated and in particular complicated to test electronic products that you can come up with. And frankly, if you've never done it before, there's no reason you would even know 75% of the things that you need to test and how to test it and et cetera. That's where a lot of our expertise comes in on the consulting side. We do a lot of help with regard to antenna selection and integration, We help people with certification, in particular certification test plans. What do you need to do? What do you need to do to get through certifications? What certifications do you need for your product based on the mission and deployment cases and all that sort of stuff? We help a lot with design verification tests and performance mitigation issues, because sometimes, like when you're doing cellular in the United States, the carrier will insist that your device work to a specific level of performance, and if it doesn't, you can't sell it. They won't sell you SIMs, and that can obviously put a grinding halt on your product development. On the design and manufacturing side, we'll do pieces of a design. For instance, a lot of customers have us do the radio piece of their product, and they go and do the other piece of their product that is their core competency. And that's pretty common. And then there are some customers that we work with where the customer has us develop the entire product, soup to nuts, sometimes even including the back end system and things like that. And that brings us to that last point. We can do as little or as much as a particular customer needs. If you need us to develop the entire product, we're happy to do that. If you need us you just need to ask us some questions every once in a while. You just need an expert in RF and certification and antennas and things like that, and related technologies, which I'll get to in a minute. That's totally fine too. We're flexible all across the board. So yeah, we're headquartered in Minneapolis. We have an office and lab space here in Minneapolis. What with the virus issues, basically everybody in our office pretty much works from home at this point, except for our hardware engineers, because they have to have that lab. We do probably 70% of the products we do are cellular, and the rest are going to be a mix of Wi-Fi and BTLE and Thread and Zigbee and LoRa and GPS and pretty much everything under the sun. And that lab has all of the equipment to be able to deal with all that, including the call boxes that are required in order to do cellular type products. You pretty much can't you can't do design verification tests for a cellular product without a call box. With 13 full-time employees and an array of contractors that are all long-time relationships of our engineers, myself, and some of the other key engineers, so that we're able to expand and contract with the work necessary, so we can be very flexible for whatever the customer needs. Some ideas on the sorts of things that we deal with. I'm not going to get too far into the bits, but we've put a lot of radio solutions into medical products. We deal with energy and sensing an awful lot. Agriculture comes up a fair amount. Pretty much autonomous vehicles and remote sensing is where we see a lot of that. Transportation, the driver logging and vehicle monitoring and all that sort of stuff. Those are all projects that have examples that we're working on at the moment. As I mentioned, we can do the whole enchilada, or we can do as little as possible. The key thing that we bring to the table is time to volume. Time to volume is important because you, as the end customer, you need to get a volume of products in the field in order for your company to make money. And EPs and PV, they need your product to get into market and in volume in order for them to make money. So our whole value proposition to everybody is to make a reliable, low-cost, scalable product that gets to market quickly and efficiently. In that context, we get asked about proof of concept type things and all that sort of stuff. We don't really do proof of concept work. I can usually explain why you don't need a proof of concept for pretty much any project. And that's something that comes up pretty often. Don't do a bunch of work and spend a bunch of time to make something that isn't going to scale. Just make the thing that scales. Some example products. This is a migraine headache treatment device. This product is an FDA controlled device. It is a medical treatment device. I believe it's a class 2 device. It did not have cellular. It did not have a radio in it at all that was being used. They came to us and said, we want to add cellular to this for logging and being able to effectively bill the insurance companies in an automated way. We came up with some antenna options for them, implemented the radio, helped them implement the software. This product is now shipping. And if you or anyone you know and care about has migraine headaches, this is the only treatment for migraine headaches that doesn't involve drugs. The apartment smart thermostats. This company came to us. They are not in the electronics business at all, and we're doing this product soup to nuts. We'll be supplying the product. We did all the design work. We're managing the back end development. We're doing all of that. This is a smart thermostat it's a low cost smart thermostat for multifamily apartment buildings. The primary thing that this is used for is for the apartment manager to be able to remotely manage access and thermostat, and thus energy consumption for unoccupied apartments in the apartment complex. Those apartments actually generate a fair amount of cost, and by you being able to remotely manage those things in an automated way, they can save a lot of labor costs and a lot of energy costs. That product, by the way, has 4 radios: Z-Wave, LoRa, Zigbee, and Thread, because it talks to smart door locks and a bunch of other things. So it acts as a gateway. And then this last little bit is just an example of the kind of things we do with antennas. We use off-the-shelf antennas. We partner with antenna companies all the time. I used to be the CTO of an antenna company, and we still work with them fairly often. But we do custom antennas when necessary. And this is an example of a custom antenna. This is a slot radiator that's cut into a beer can. I live, and the company is headquartered in Northeast Minneapolis. Northeast is literally our hometown brand beer. This is a 2.4 gigahertz slot antenna that covers the entire 2.4 gigahertz band for Wi-Fi or Bluetooth or any of that sort of stuff. That cut into the metal surface is the antenna. The enclosure, the piece of metal, is the antenna. And if you can imagine that being a big metal box with your electronics on the inside, you can cover that slot with either a rigid plastic part, if it needs to be rigid, or something as simple as a vinyl decal, and you have a metal box, and the metal box is the antenna. It's kind of one of the things that we show off a little bit, because look, it's a beer can. So that's kind of the quick run through there. One last thing I was going to mention was one of the things that is part and parcel of doing wireless products is low power management in general, batteries, and all of those things. Those are things that we deal with every single product, and we're very good at it. And I got to tell you, I hate batteries. Batteries are always the weak point in the product. Any way to remove that battery as your single Achilles heel is going to make that product way more reliable and that's why we put this whole presentation together, because the combination of these solutions really creates a powerful incentive to be able to do that sort of stuff. I'll throw it back to Joe, and then we can see about questions.
Thanks, Chris. Yeah, one quick question that somebody just sent in. They were asking about the latest Bluetooth modules that you're using.
So there's a couple. So how to answer that quickest? So we will implement modules, usually for cellular. We do this day in and day out. Honestly, for Bluetooth, we normally use a chip down solution. We don't normally use a module. If you have a module that you want to use, we're totally fine doing that. Normally we do a chip down. We also have the advantage, we're licensees with a lot of the high-end silicon folks. For instance, Qualcomm, we're a Qualcomm licensee, so we can do chip level solutions for high-end Wi-Fi, the latest generation fast Wi-Fi. This whole Wi-Fi 6E thing that's going to be coming up here towards the end of the year is going to generate a lot of interest in those solutions. In BTLE, I would say we probably use Nordic the most, but we've also used Dialog. We've used Silicon Labs. I'm trying to think who else. Those are the ones that jump out at me off the top of my head. But we can do chip solutions pretty much across the board, and that includes cellular. A cellular chip level solution can get you to a very, very low unit cost, which actually combines really well with the solar and low power consumption solution if you've got the volume to support it. You need something that costs $30 because you're gonna literally ship 10 million of them, that kind of thing. So,
okay, thanks, Chris. Sam, a quick question, not a quick one, but there's a question that came in a while ago when you were presenting. I'll read it to you. I don't know if you can see the chat, but it says, regarding the placement of PV versus power generated, do you have any formula on power generated versus unit area of solar panel, like 1 square inch? And is it linear when you scale up to 1 square foot?
Yeah, so I mean, if you go to our website, we have a couple tables. That's something you can, off the top of my head, like an indoor environment, you get 5 microwatts per centimeter squared at 200 lux. But we rate our panels at 200 lux, 1000 lux, quarter sun, full sun, and that does scale pretty linearly with surface area.
Okay. And Brian, I don't know if you're still there. You had a question earlier about
perovskite. I was asking about perovskite. Yeah, just for the fun of it, since he was kind of doing a compare and contrast. I mean, this is far more kind of on the emerging side of things, but just want to get his 2 cents on that if he has it.
Yeah, I almost labeled that last category as other, and I would the PV or the perovskite PV into that category as something that is kind of emerging, but still kind of figuring out the niches. But definitely, I mean, it could be the source for the future, or it could fizzle out.
Okay,
fair enough. Thank you.
Thanks, Sam.
Yeah.
Chris, one more question about somebody just asked if F3 Wireless will do device firmware development support.
We have an entire team that does. Well, we have multiple teams because we have a team that does pure embedded, so C on bare metal, embed, FreeRTOS, micro CR OS, things like that. And we have another team that does embedded Linux stuff that focuses on low power embedded Linux, and we can actually say those words and that not be a punchline to a joke now, because you can actually have a low power embedded Linux system that will in fact run off of a solar solution at this point. And then beyond that, there's another software team that does production testers, and another software team that does backends and cloud integration type work.
Okay. Great. Well, that's all the questions I see. We answered some of them through the chat. So there's none I see pending. So with that, we'll wrap up. Again, I really appreciate everybody's time. Hopefully you found it valuable, learned something about energy harvesting, and again, feel free to contact myself or any of the presenters about the materials. And if you're interested in eval boards, data sheets, app notes, or just want to chat about power budget analysis and what ifs kind of thing, we have a lot of expertise in that area and would love to help you out. Sam, any last words?
If you want information, go to our website, powerfilmsolar.com, or reach out to us or contact us.
Yep,
Great.
same here. Just f3wireless.com, and there's a contact form on there, or you can email me directly from the email address in the slides, chris@f3wireless.com.
Fantastic. All right. Thanks again, everybody. Have a good rest of your day.